Hello class, in this video I will be showing you an application of the derivative. Let's begin. For example 10, we have the cost in hundreds of dollars to produce X hundred pieces of gum can be modeled using the formula C of X is equal to 0.05x plus the square root of the quantity 0.2x squared plus 25. Part A asks to create the marginal cost function. The marginal cost function measures the change in cost. And the change in cost is measured using the derivative. So we need to find the derivative of C of X. So I'm going to start by rewriting C of X as such. Notice that all I did was replace the square root with an exponent of 1/2. Now to find the derivative. C of X consists of two terms. The first term is 0.05x, and the second term is the quantity 0.2x squared plus 25 raised to the 1/2 power. Since there are two terms, we are going to find the derivative of each term separately. So we have the derivative of C is equal to 0.05 plus, now the second term requires the chain rule. I'm going to let y equal u to the 1/2 power, and I'm going to let u equal 0.2x squared plus 25. The derivative of y with respect to u is 1/2 u to the negative 1/2 power, and the derivative of u with respect to x is 0.4x. Applying the chain rule, and we have the derivative of y with respect to x is 1/2 times the quantity 0.2x squared plus 25 raised to the negative 1/2 power times 0.4x. Now I'm going to go ahead and multiply 1/2 times 0.4. So the derivative of the second term is 0.2x times the quantity 0.2x squared plus 25, all raised to the negative 1/2 power. And this function is the marginal cost function. Now to part B. Assume that 400 packages of gum are made. If 500 packages of gum are produced, what is the approximate increase in total cost? Okay, so if we have 400 pieces of gum produced, we could write this as 4 followed by the word 100. And this implies that x is equal to 4. For 500, we could write that as 5 followed by the word 100. And this implies that x is equal to 5. The problem is asking for the approximate increase in total cost. Since we started with 400 packages of gum being made, we are going to evaluate the derivative when x is equal to 4, not 5. And we're going to do this in Decimus. So I've already gone ahead and entered the function into Decimus. Now all that's left to do is to evaluate the derivative when x is equal to 4. So we have c prime of 4. And that is approximately 0.2006. Now remember that cost is in hundreds, so we have the following. If the number of packages of gum produced increases from 400 to 500, the total cost increases by approximately $20.06. And we are done.